Hi everyone, my name is Mahendra. You are watching Mahendra tutorial. Today I would like to explain about refraction of light at curved surfaces. What is refraction? Refraction is the bending of light when light travels from one transparent medium to another, like from air to water or glass. This happens because the speed of the light changes in different media. Here we can see two different mediums are there. One is air, another one is water. The perpendicular line which is passing from air to water is known as normal. Now a ray of light falling on the surface, that is known as incident ray. When it is traveling from air to water, it means rarer medium to denser medium, it changes its direction, it's bending. So the refraction of light is when light is traveling from one medium to another medium, it changes its direction. It is known as a refraction of light. Let us see one numerical. A bird is flying down vertically the surface of the water in a pond with constant speed. There is a fish inside the water. If that fish is exactly vertically below the bird, then the bird will appear to the fish to be. Options are A. Farther away than its actual distance, B. Closer than its actual distance, C. Moving faster than its actual speed, D. Moving slower than its actual speed. See the situation. Here is the bird and there is a fish inside the water. The bird is exactly above the fish and it is assumed that it is moving vertically downward. Here the ray which is incident ray which is traveling along normal, it is undeviated, it goes straight. And we draw second ray, it is making some angle with the normal, that is why it is bending. So if we extend the refractor ray backwards, this refractor ray appears coming from this position. And when we extend this first incident ray which is passing through the normal, if we extend back, these two rays appear meeting at one point, intersecting at this point. Here is the actually image of the bird is formed. So for the fish, the bird appear to be farther than its actual distance. You can see x is the actual distance and here is the object and y is the image distance. So in the point of view fish, the bird will be at farther than its actual distance. Let us derive this theoretically. Here N1 is the refractive index of air and N is the refractive index of water. Solution. For the refraction at plane surface, we have one formula, N2 by V is equal N1 by U. It is equation number 1. Let x be the height of the bird above the water, here to here x from the surface of the water, and actual height of the bird is x at instant, and n be the refractive index of water. N1 is the refractive index of air. Then N1 refractive index of air value is 1 and refractive index of the water is n. U is minus x. Here we are applying sign conventions. Incident light is downward but measuring should be upward. That is why we have taken minus symbol here, minus x, and image distance v is also minus y according to sign conventions. Substituting these values in equation number 1, n by minus v, because in the place of n2 value we are writing n, by v value we are writing minus v, is equal to n1 value is 1 and u value is minus x. Substituting these values in the equation number 1, n by minus v is equal to 1 by minus x. After solving this, y is equal to nx we get. Here we know that n value is greater than 1. It means y, image distance, is greater than x. So image distance is greater than the object distance. So for the fish, the bird will appear farther than its actual speed. Y is equal to nx. In the above equation, we know that n is greater than 1, hence y is greater than x. Thus, the bird appears to the fish to be farther away than actual distance. Next, we have to see the speed. We have to assume that bird is flying vertically down with constant speed. For the observer on the ground, the bird appears that it has covered x distance only for certain time. But for the fish, it appears the bird has covered y distance in the same time. So if you see the previous one, when we observe from outside, the bird has to travel only x distance. But in the point of view fish, in the same period of time, it has to travel y distance. It means for the fish, the bird appears very faster than its actual speed. But for the fish, it appears that bird has covered y distance in the same time. As y is greater than x, we conclude that the speed of the bird observed by the fish is greater than its actual speed. So the correct options are A and C. Come here. Thanks for coming. The class is over. You can go now. Bye bye.